All right, so today we're starting a new unit. It's going to be about signed numbers. So let's get started. All right, so an introduction to signed numbers in general. Signed numbers permit operations where there's more than one sign involved. So pretty much we're going to start with just a general overview today. First, we're going to talk about, let's see here, the set of integers. So how do we write them out? There's two major ways, a list and a number line. We're going to talk about both of them and how we use them. The next part is we're going to talk about what exactly qualifies as an integer and how do we identify them. And the third important part, we're going to talk about this in the next video actually, is how do you order integers. So there's different ways to do it. There's ascending order, descending order. You can also directly compare two integers, and you can also compare non-integers. So we're going to talk about all that good stuff. But basically, the one thing I wanted to talk about, which is right here, is that this is pretty much the preamble to order of operations, which luckily we already did in Module 2. So a lot of this stuff might be review. You might also know what to do from previous classes that don't really comprise of Spirit of Math. So all that good stuff is going to be definitely very helpful for us moving forward. But just to give you an idea of where we're headed from here. Okay, so here's a preamble to the whole section, and it's this whole controversial part about calculator usage. Now, traditionally, signed numbers is taught in a way which does not involve using calculators. So calculators are generally prohibited on tests and on the final exam, and this is how everything ran sort of pre-pandemic. And so it would generally involve a lot of mental math. However, as you know, in March 2020, the whole thing broke down. The whole pandemic sort of flew open. Things began to shut down. And pretty much at that point, it became futile to say, hey, you shouldn't be using your calculator for this reason, for that reason, for the other reason. And so it became commonplace for everyone to just simply use their calculators. Now, hopefully, with the advent of all of our vaccines, we're going to be in a post-pandemic environment. The question remains, however, whether we are going to be using calculators or not. And to be honest, I don't have the answer to that question. We might be continuing with using calculators. We might not. So we need to prepare you in such a way where you don't have to use a calculator and in which you are okay checking your work with a calculator. So both of those two things are going to be super important. All right. Now we're going to talk about the set of integers. So what exactly do we mean when we say this? Well, what qualifies as an integer? The set of integers, which is commonly written out as this z. This is z here. This z has a straight part, and then it has sort of a two of these diagonal motions, and then another straight part. And this is what incorporates of the set of integers. And there's three key components of it. So the first one is all the negative numbers, right? So all of your negative numbers, they all count as integers. Then you have 0. A lot of people think 0 is positive. With due respect to these people, that school of thought is now falling out of favor. 0 is officially neither positive nor negative. So it's sort of a wild card. And so 0 is involved in the set of integers. And then also we have all your positive numbers. So all your counting numbers. So if there was 10 things, you would count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of your positive numbers, they all definitely count as your counting numbers, right? So they all contribute to this set, and those positive numbers are given this abbreviation of this n, right? And so you have all these examples of integers. We have 7, -5, 20, and -20. All these things qualify generically as integers. Now, how do you write out integers? There's two major ways we can do this. The first way is using a list and an ellipsis. Now, the ellipsis is the code word for this ... thing. And all this ... thing means is that it goes on forever. So, for example, the list I have here, it has 1, 2, 3. The next number, as you know, of course, is 4, and then 5, and then 6, and so on and so forth. The other way, we have 0, -1, -2, -3, and so on and so forth. And so the way we write out our entire set of integers, again, this double-lined z, is to put all of those three things together. So let's quickly jump back to the previous slide. So we had negative numbers in green, 0 in red, and positive numbers in blue. And it's the same idea. So our negative numbers in green They are all of our negatives. So again, we list out -1, -2, -3, and then we have this dot, dot, dot thing going on. Then we have 0 in red, and then in blue we have all of our positive integers, which are 1, 2, 3, dot, dot, dot. Those are all of our positive numbers, and that's what we list out. This entire thing together is pretty much the entire set of integers, right? You can't really think of any integer. For example, if we had -5, for example, it would be -1, -2, -3, -4, -5. It's all included in this umbrella term right here, okay? Now, another way to do the exact same thing is to just use a number line. The number line is easier because you don't need these brackets, you don't need this dot, dot, dot thing, and all of that is replaced with this arrow. So again, an arrow, just like the ellipsis, means it goes on forever. So your positive numbers go all the way, your negative numbers, again, go all the way. And again, you have the same setup. So we have -1, -2, -3, we have 1, 2, 3, and you have 0. So both of these ways are ways in which we can write out our entire set of integers. Okay? And again, as we said, both the list and ellipsis way and the number line way need to incorporate all of the different parts of what we know as an integer. So all of our negative numbers, 0, and all of our positive numbers. Okay, so now we've talked about what is an integer, namely our 3 components, but what's not an integer, right? So we have the 3 components, but what is not an integer, right? Basically, anything that's not included in the previous section is not an integer, obviously, but I want to emphasize a couple of points here. So first of all, any decimal, by definition, is not part of the set. So any mathematical operation that does not simplify in any way to give us a whole number, most notably these include your fractions, mixed numbers, and square roots. So I have here an exercise for you to do, and I want you to simply circle any integers and cross out any non-integers, okay? So go ahead and do this, and we will take this up very shortly, okay? So I'm gonna give you 5 minutes. We have 5 questions. We have root of 81 over root of 9, 2 1/3, 12 over 4, 0, and the cube root of 8 over 8. And I would like you to, again, circle any integers and cross out any non-integers. Go ahead. All right, so that is time. Let's go ahead and take this up now. Okay. Here, let's move this over a bit. Just so I have some more space to work with. All right. Okay, and we're going to go back to the slideshow from current slide. Okay, that's a bit better. So now, using our pen, we're going to go ahead and actually do this. So, first of all, we're going to simplify everything as much as we can. So for question number 1, we had square root of 81 over the square root of 9, right? Now we can actually do both of these operations. So the square root of 81, as you must know, is equal to 9. The square root of 9 is equal to 3. And 9 divided by 3 is equal to 3. And this is an integer, right? So even though it has a bunch of square roots, and I said that in this section here, anything that basically has a square root might not count, but technically we can simplify all of those square roots to give us a number that absolutely is an integer. So in this case, we will put a nice circle around this, and it would be an integer. So just because something has a square root doesn't mean it necessarily is not an integer. You do have to do the math and make sure that what you said is an integer is actually genuinely an integer. Okay? Now let's go ahead and do the next one here. I'm just going to erase this here. And now we're going to do 2 1/3. Basically, when you have a mixed number is a dead giveaway, basically, because you're saying it's 2 1/3, right? Now, if you think about this in terms of our number line, right, if I redraw a section of our number line, and let's say 2 was over here, and 3 was over here, 2 1/3 would be right over here. Now that is not 2, it's also not 3, right? And it also wouldn't be part of our counting numbers. No one counts 1, 2, 2 1/3. That doesn't happen. It's always 1, 2, 3. So in this case, we would say 2 1/3 is not an integer. Okay? Any mixed number is never going to be an integer. Just in general, when you see a mixed number, you can always just simply cross it off. Okay? Let's go ahead and grab our eraser here. Okay, and let's continue. Right, we have 12 over 4. In this case, again, we can simplify. We know that this fraction line also means division. So if we write this as a division question, right, we can say it's 12 divided by 4, which is equal to 3, right? At this point, I want to remind you of this point up here. I intended on saying it earlier, but I guess I just forgot. If you are done early, please take the time to grab a calculator. I don't really have one on hand here, but you can grab a calculator and you can check, you can plug in everything and make sure that what you get on your calculator matches what we have here. Okay? All right. So this is circle. 0, we talked about this. This is absolutely an integer. Again, the cube root of 8 over 8. Let's take a closer look at this. So we have, in this case, a cube root of 8 over 8. As we said, 8 over 8 is like a division question. 8 divided by 8 is equal to 1. The cube root of 1 is actually equal to 1 because 1 times 1 times 1 is equal to 1. So in this case, this is also an integer, right? So on a cursory look, you might have thought, hey, look at look at this and look at this, and both of those look like, hey, you know what? That's not really going to be an integer. But if you think to yourself, to review and to revise, you will find out that that is actually not the case, right? And that it is pretty much an integer, and it is ready to go. All right. So that is the idea here. And we're basically done. Now we have circles and crosses over pretty much all of these numbers. Okay? And we are actually done. So that is it. Our next video is going to talk about ordering integers, so please stay tuned for that. All right. Whoops. Take care and have a good week.